Chemical reactions. Understanding chemical reactions is fundamental in chemistry. Let's dive into how atoms rearrange during chemical reactions, the law of conservation of mass, and how new substances are formed. A chemical reaction is a process where substances, reactants, undergo a transformation to form new substances, products. This transformation involves the rearrangement of atoms. Atoms rearrange themselves in a chemical reaction. In chemical reactions, atoms are not created or destroyed. The atoms at the start of a reaction are still there at the end. Bonds get broken and made in the reaction, as atoms rearrange themselves in going from the reactants to the products, but the atoms themselves are not altered. In a chemical reaction, reactants, the starting substances, products, the new substances formed. During the reaction, the atoms in the reactants break their existing bonds and form new bonds to create the products. The law of conservation of mass states that mass is neither created nor destroyed in a chemical reaction. This means that the total mass of the reactants equals the total mass of the products. Why this happens? Atoms are not lost or gained in a chemical reaction. They are simply rearranged. The number of each type of atom on the reactant side must equal the number of each type of atom on the product side. Chemical reactions do not involve a change in energy. In other words, reactions always give out or take in energy. This is usually heat energy, which causes the temperature in a reaction to go up or down. Visible changes can also occur in the reaction mixture. These show that a reaction has taken place. For example, a gas comes off, a solid is made, or the color changes. In chemical reactions that produce a gas, the mass in the container might drop as the gas escapes. The total mass of the products is always equal to the total mass of the reactants, though. Let's look at an example. Marbles react with hydrochloric acid to produce carbon dioxide. If the carbon dioxide can escape, the mass in the conical flask is reduced, but if the gas is collected, the mass stays the same. To show that mass is conserved, chemical equations must be balanced. This means the number of atoms of each element must be the same on both sides of the equation. When reactants interact, bond breaking, the bonds between atoms in the reactants break. Rearrangement, atoms rearrange and form new bonds to create the products. Understanding these concepts helps explain how substances change in chemical reactions and ensures that the fundamental principle of mass conservation is always followed.